Welcome to homework.
31.34. So we have an AC generator hooked up across a capacitor. First, we want to find what the magnitude of the current through the capacitor is. We want to say what the EMF from the generator is when the current is at its maximum value. And then we want to find what the current is when the EMF from the generator is at negative 1/2 its maximum value and is increasing in magnitude, which means that it's becoming more negative. So like at this point here. So first things first, we know that the amplitude of the current is going to be the amplitude of the EMF divided by the reactance of the capacitor. The reactance of a capacitor is 1 over omega c, so 1 over omega c is just omega c. And this gives us a value of 39.1 milliamps. Yeah. Now, when the current is at its maximum, the charge on the capacitor is changing at its largest rate, sort of by definition. And because we know this is going to be sinusoidal, the largest rate of change occurs here at 0. Now, when the charge on the capacitor is 0, the voltage across it is also 0, which means that the EMF from the generator also has to be 0, because otherwise the Kirchhoff's loop rule would break. So when the maximum current is flowing through the capacitor, the voltage or EMF across it is 0. And this is, another way of thinking about this is that the phase for a capacitor is negative pi over 2. So if something is pi over 2 or 90 degrees out of phase with some other thing, then one of them will be at maximum when the other is at 0, and vice versa. So now for this question of the current when there's a particular value and direction of change of the EMF. We know that E is its amplitude times, its time dependence. And we're saying that this is equal to half its maximum value, which is equivalent to saying you just divide both sides of this by E sub m, that we want a time t such that sine of omega dt equals negative 1/2. Now, there are 2 such times per cycle, which is why we're also told that it's decreasing. So the derivative of this is omega d cosine omega t. And we need this to be negative. We don't care about what its value is, just that it's negative. So in order to satisfy both of these things, we need for omega dt to be equal to 2 pi n, because this is going to repeat every cycle when you've accumulated a full 2 pi radians of phase. And then what ends up satisfying the value of phase that satisfies This, and also has a negative cosine, is negative 5 pi over 6 radians. N is an integer here. So we know that I is the sine of omega dt minus the phase constant for the given circuit with an impedance, a complex impedance. Phi is negative pi over 2, so that'll be positive here. So we just put in, it's equal to its amplitude times that, sorry. So sine of now omega dt needs to be 2 pi n minus 5 pi over 6, then a plus pi over 2. And so simplifying that, we get our 39.1 milliamps times negative square root of 3 over 2, which is negative 33.8 milliamps.